Here's another parametric equation free response question. This is from the 2016 exam. Number 2, a calculator is needed for this one. Okay, so we're given a graph in this case, so that's why I chose this one. A little different than some of the other ones I filmed. So this one says at time t, the position of a particle moving in the xy plane is given by parametric functions x of t, y of t. They give you dx dt as that guy. The graph of y consisting of 3 line segments is shown in the figure above. At t equals 0, the particle's position is at 5, 1. Part A, find the position of the particle at t equals 3. Okay, so we can find the y coordinate, y position of the particle just by this graph, because this graph is y of t, the position of y with respect to time. Okay, so y of 3, the y coordinate at t equals 3, looks like it's minus half, right? Negative half. Okay, so that's what I wrote right there. Now what about the x coordinate? We're given this differential equation right here, right? And we have an initial condition. So can we solve for this? We would have to find the antiderivative, which is hard for this one to find. It's hard to find the antiderivative for this one by hand. Okay, so since this one a calculator is allowed, this is a very typical question actually. Let's use the fundamental theorem of calculus. X of 3 minus x of 0 equals the integral from 0 to 3 x prime of t dt, or dx dt as x prime of t, okay? This you can plug into the calculator. F int of this guy, comma x, replace the t's with x, comma 0, comma 3. That will give you this right-hand side, okay? X of 3 is what we want. X of 0, they gave us as 5 right there, okay? So, minus x of 0, so I move this to the other side, so it becomes 5 plus this integral. Again, put this in the calculator, you should get 14.377. So the position at t equals 3 is 14.377, comma, minus 0.5. All right, part B, find the slope of the line tangent to the graph of the particle at t equals 3. So we got to remember how to find the derivative of a parametrically defined equation. That's just dy dt over dx dt. That's equal to dy dx. So what's dy dt at t equals 3? So what's y prime of 3? What's the derivative? What's the slope of the tangent line there? What's the slope of this line? It looks like it's rise of 1, run of 2, right? So it's half, yeah, or 0.5. What's x prime of 3? Just plug in t equals 3 there. Yeah? Put this in the calculator, you get 0.05. Okay? Part C, find the speed of the particle at t equals 3. This is very typical. Speed is the magnitude of velocity. So square root of x prime of 3 squared plus y prime of 3 squared. Okay? Put this in the calculator, 9.969. Very typical. All right, part D, find the total distance traveled by the particle from t equals 0 to t equals 2. This is just arc length. Parametrically defined equation to find the total distance traveled along the curve. That's just the length of the curve, arc length. So that's integral from 0 to 2. They told us that, right? Dx dt squared plus dy dt squared, all in the square root. Okay? So dx dt, that's right there. Dy dt, well, what's dy dt from 0 to 2? Well, it changes. That's the tricky part for this one. So you got step 2 integrals, actually. So, integral from 0 to 1, dx dt, they gave you as an equation, so that's nice. But from 0 to 1, your dy dt is how much? Minus 2, right? The slope is minus 2. Derivative is slope of the tangent line. So, minus 2 squared, right there, okay? And then your second integral from 1 to 2, your dx dt is still that guy. But what's the slope of the tangent line from 1 to 2 here? It's 0. Okay, so plug this into your calculator. So f int dx dt squared, you should store that as an equation probably, plus 4 under the square root, by the way, comma x, comma 0, comma 1. Okay, close the parentheses for that, plus f int square root of dx dt squared, comma, and close the parentheses as you need to, comma x, comma 1, comma 2. And then you should get 4.35. Okay, so what's the unique problem? Part of the problem in this specific free response question is probably part D. Otherwise, if you've seen other free response questions, usually it's number 2, at least in the past 10 years. Position using this technique of fundamental theorem of calculus is very standard. Slope of the tangent line, that's pretty standard, that's the derivative. Speed, that shows up very often. Magnitude of velocity, this one's the, not new, the concept per se of arc length, but because this graph is given, it's a little different, so we have to break it up. And that's how you understand it, as I explained, all right? Hopefully this was helpful. Please give this video a like if it was, and hopefully I'll see you in another video as well. Bye.